Innovations, Zyma Solutions, IBM Innovation Center for Education, and Micro Focus Software University Program. His commitment in advancing the technical education through faculty development program. He has conducted many FDPs under the ASP itself. And currently, Mr. Harsha holds a strategic leadership role at his current organization, that is Silicon Microsystems, where he drives education-focused business operations. His responsibility empowers providing design services in VLSI, embedded systems, and PCB solutions, delivering specialized training program and facilitating talent acquisition and deploying for leading semiconductor companies. Additionally, he spearheads the establishment of centers of excellence in advanced embedded systems, AI, IoT, 5G communications, technologies, lower power VLSI designs, and PCB prototyping, and more in engineering institutions across India. Okay. So it is really a privilege, sir, to have you here. Thank you for spending your valuable time, and I invite you for delivering the guest lecture. And one more announcement is tomorrow the venue is changed to the CAD Center, which already you visited the hands-on experience. So tomorrow morning directly come to the CAD Center. Okay. So today the program is we'll have the session followed by the hands-on experience from iRobo Solutions. Okay, so you can put more of practice on the software, robotic softwares. And if you require the software, you can get it installed on your respective laptops. Or if you carry a pen drive or something, you can always install it yourself. Okay, so thank you.
So good afternoon, one and all. My name is Harsha Nilakanta from Silicon Microsystems. So sir gave some brief profile. This is what happens in MSME sector. So you have jack of all trades. So we work with multiple domains, and based on the project what we get, we work on that. And I started my career as a robotics engineer back in 2009. So from there, my journey in robotics have started. I came to know that some of the participation from Tamil Nadu institutions. So we are also partners of ABB Industrial Robot and Mitsubishi. So I alone have set up around 20 industrial robots in Tamil Nadu institutions, because the Tamil Nadu under Anna University, they had brought in a new branch, mechatronics, almost 10 years back, and a lot of so it is said that any new changes, first it will happen in Coimbatore region, then Chennai region, then entire Tamil Nadu, then rest of India. This is the process that follows. So I heard that some of you have come from Venkateshwara College. So principal is Ganesh sir, and since we are a core electronics company, we have a constant touch with electronics people. I think Dr. Satish sir is the HOD. Retired, is it? Okay. And one of the embedded faculty I had met is Ramya madam. I think they are in the electronics department. So I have traveled extensively in South India, established multiple labs. So just to give a brief background of our company. So we are a core electronics company, and we are there from past 27 years. We started as setting up basic academic labs, starting especially in electronics domain. Very basic labs from third semester to all the semesters. And over the periods, we have given a lot of inputs to Anna University, JNTU, VTU, where they have adopted some of our syllabus, equipment, and then we have established in the colleges. And our CEO was in multiple beers committees where we brought in a lot of changes. Uh, so I think there is a larger mechanical crowd here. So electronics, if we say Xilinx, that is one of a top company where they are into chips. So we brought Xilinx to education market in India back in 98, 99. And from there, we have moved, and post pandemic, uh, almost 3 years we do not get any business from education sector. So as a necessity, we moved towards industry, and where we started some projects on design services, particularly in VLSI, embedded, and PCB design consultancy. And our unique feature of our company is we are not just there in electronics, we are also there in robotics and automation. And we were the first one to bring robotics education in India back in 2003. And we were too early to the market. When we said robotics for school children, they used to shut the doors in the gate level itself. There was no entry. Only after 2015, 2016, Government of India, they came up with something called Atal Tinkering Labs in the schools. So first time, schools got funding of almost 20 lakhs to set up Makers Lab or Idea Lab kind of a thing. So that's where now you have many companies who's doing a lot of robotics lab setups in schools. So why I'm stressing on schools? Because they have already started in multiple fronts, including on the AI part. And unfortunate to say, engineering colleges are lagging behind on this aspect. And this is a very unique seating setup. It's V-shape. Okay. So these are the domains, core electronics. So we have a legacy of over 27 years. We have developed more than 200 products, especially for education sector. And some projects we have worked in aerospace, defense, as well as in railways. So if you see the recent projects on aerospace sector, we are the first Indian company to develop a digital cockpit display system. So till now in India, we did not have, because even the technology wise, the cockpit now they used to use analog system. So now they are migrating to digital systems, where again, if any aerospace company want this digital display system, they used to import from Germany, US, or Japan. So recent Bangalore Air Show, we have displayed this. And one more is on embedded front. In Bangalore, there is something on Bangalore traffic signals. We call it as VAC, Vehicle Activated Control. So whenever you come to Bangalore, you just notice that. So earlier your signaling system was more into timer based. So now it is more into density based on machine learning and AI features. So this order was taken by Honeywell, and complete machine learning algorithm as done by us. So multiple front we are working. Currently we are working with 6-7 projects on Indian Railways. Again, if you see Indian Railways signaling system, what was developed 50 years back, still been utilized. Though we talk about Vande Bharat train or Kavach systems. So like this, we have contributed to many industry and defense sector. And we were the first training institute in VLSI back in 2001. So that is a core domain. So now there is a huge demand for the VLSI part. So that is where your engineers work on chip design. So currently there's next 10 years, it's an exponential market for semiconductor industry. So what we saw 30 years back on the IT sector, the you saw IT companies taking students from mechanical, civil. The same kind of scenario will happen in electronics, semiconductor industry. Only problem is we cannot go with mechanical engineers. We require core electronics, electrical. The best next thing we can go is computer science. Okay, and especially this is happening. Uh, if you don't know, not having the awareness what's happening in Karnataka recruitment circle, last 2 years back, automotive companies like Rolls-Royce, Mercedes-Benz, they wanted core electronics engineers with Python and C background. So they did not get the talents, so they hired from computer science. And after 2 years, they have laid off them. Why? Because the project has moved to the next stage. Software part is done. Next comes your sensors, controllers, integrating display systems. So that without any basic electronics knowledge, you cannot go forward. So next, what is industry facing difficulty here is core electronics engineers not very well versed with C or Python. So most of the things are happening. I'm a alumni of Sairam Bangalore. So basically, we have a lot of industry in Osur industrial area, especially TVS, automotive company manufacturing units are there. So regularly we are training students in Sairam, and regularly the TVS is hiring mechanical, electrical, electronics only because of the Python knowledge. Okay. So over the years, we have partnered with multiple companies. Yeah, as I told you, ABB Robotics. We have constant education partners. We set up industrial robots in the academic institutions. Then we have Yokogawa Automation Products, Mitsubishi. All these are related to mechanical. Rest all what you see, Dilab, Datasol, they are into aerospace sector. Rest all is electronics domain. So one more is we have partnered with many organizations. We are doing something called finishing school concepts in the campuses. So that is more into training students from third semester itself, irrespective of the branch, mechanical or electronics or computer science. So we groom them, and when they come to 8th semester, we try to provide our own projects, so that now we can identify good prospective and then we hire. So this is backed by IEEE, each semester certified by IEEE, and we create that placement ecosystem. And apart from that, I told you there's a lot of growth in semiconductor industry. In IT sector, if you see, the government has come up with something called DEI. You are aware of it? DEI, diversity, equality, and inclusivity. So this is something which any company, when they are running, they have to have this. When we say equality, that means male and female ratio should be same. So in IT sector, it's almost same. But if you come to the semiconductor or electronic sector, female ratio is almost less than 20%. So that's where we have a special programs under NASSCOM. So NASSCOM is again more than 3,000 electronics, IT companies are members in that, all top tech giants. And IESA is Indian Electronics Semiconductor Association, where we create what is happening in the semiconductor industry. We create the awareness in the campuses. And these are some of the big disruption that is happening in the electronics market. RISC-V, so it's more of when you develop a chip, you require a architecture. So ARM is one of the architecture, and RISC-V is more of a open source. So IIT Madras, they came up with Shakti processor. So this is widely used in multiple application. Recently, Shakti processor was used in launch of one of the satellite in ISRO. Why I'm stressing on this is, these are the Indian microprocessor and microcontrollers. So that's where you can build your robotics using these controllers. That this becomes more of indigenization. So like this, we have multiple association, and we have trained on multiple domains. We have conducted more than 300 faculty development programs over the years, and we have done multiple programs, lab setups. So I told you about Atal Tinkering Labs. You have Atal Incubation Center, where almost 10 crores funding was given to the institution to set up Atal Incubation Centers. So we have set up multiple centers across India. Now recently, AICTE Idea Labs. I think in Tamil Nadu region there are 94 institutions received it. In Karnataka around 41, and in Andhra around 70-80 institutions have got it. So we are establishing Idea Labs also. Okay. Now this was a just brief. I know post session is always a tough session, so I'll try to make it quick, fast, and I'll show you some videos. Okay. So when we say robotics domain, there are a lot of revolution that has happened, especially the industry revolution. So that's where most of your automation and electronics, all these parts came in, and that's where robotics also came into picture. So when we say automation, it started with just relays in the form of just on and off. So it's more like a switch operation, and from there, ultimate goal of robotics domain, what you want robots to do? Basically, you want a humanoid robot which it can be a slave for you. So that is the ultimate goal. So basically, you know what are the features it requires? Controller, main brain, then sensors, actuators, and all these systems. Then comes your power and communication. So this is where a lot of research activities are happening. So when I say communication domain, I can again I can go into deeper part of electronics, but I'll try to restrict that. All I can say is, for example, Operation Sindoor. So during Operation Sindoor, you saw many drones coming from the opposite side, and very 0.01% drones came inside and fell in the Indian territory, right? So this is more on a advanced level of application, where communications plays a very vital role. So earlier you had a technology where any particular opposite enemy, a missile or drone is coming, basically you will have a laser pointed at that, and once it laser is fixed, then the missile or the bullet used to go. But that has changed completely now in technology wise. So all we require is the rate at which it's coming and the location at which it is there. So that's how India successfully broke down all the drones which came from the opposite side. And believe it or not, it was done by just one of the startup in Bangalore. So this more concentrates on communication part. So that's where a lot of researchers are happening. So when you come to the types of robots, so robotics is a domain where you don't have any research. So what robot you develop, that is your research. So basically it's an application oriented domain, and when you classify these applications, there are different categories. As I told you, industry applications, then mobile robots, service, medical robots, swarms. So in this particular application that most of the academic circle miss is prototyping of robot. Heard of it? Prototyping of robots. So in school days you might have studied to get one input and output, you keep a black box in the center. So this prototyping of robots is nothing but a black box. So usually when you decide on any particular application, you don't go for large scale development, because more or less the development of robots is more of trial and error. So what happens to reduce the cost? First you do a prototype model. So where do you do this prototype model? Only when you have controllers, sensors, building materials like gears, screws, axles, pulley, then only you can integrate and make a prototype. So even if you see the ISRO's Chandrayaan projects, the rover, it was never developed full stage. First a prototype level was done. So we are talking about these kind of prototyping kits that most of the institution need to have. Video. Minimize. First video. Video one ante. Okay. So one of the famous prototyping kit is Lego. Heard of Lego? So Lego is basically a toy company. It's a more than 100-year-old company. Started in 1905 with wooden duck as a toy. And over the years, they kept on manufacturing multiple toys. And somewhere in during the Gulf War period, that is somewhere in 1991, they went bankrupt. So they were manufacturing more, but not selling it. So they had to innovate. So that's where they came up with the concept of prototyping. So they came up with what model is called, it's NXT. So it's just one small example. So you might have seen the Rubik's Cube where you can solve. So basically it has got particular algorithm to solve this cube. So that algorithm you program it, and there are particular where's the pointer? Red one? Okay. So there are different sensors here. If you say this is an ultrasonic sensor, then there is a color sensor, and these are some servo motors. One motor is here, another motor is here, and all these parts what you see, it's all you can assemble and disassemble. So you can use for multiple projects. It's not just fixed for one particular project. So basically there is a main controller here. So NXT uses ARM7 controller. So this is a video. Have you seen this video? No? This is a video of almost 13 years back. Sound ಅಷ್ಟನಾ ಸ್ಪೀಕರ್? Okay, so almost the colors are getting sorted. So this is quite sleepy, right? To watch this video. So I'll show you the next video, the level of the complexity that you can build using this prototype. Okay, the same Rubik cube solver. This is a simple model. So when I say prototype level, you have multiple stages that you not need to go, multiple trial and error methods you have to try, and once that is done, it's all set. So basically it's taking around 3 minutes to solve this. ಸ್ವಲ್ಪ forward ಮಾಡಿ. In 30 seconds, leave it. Leave it. So it's completed in 3 minutes 20 seconds. Play the second video. So this project was done by one of the South Korean engineering student. Okay, the same kit, the level of design and the complexity is built more in better way. So here you have multiple controllers, multiple sensors. Here they have used touch sensor. This is a touch sensor. Servo motors. So this is a basically operating in X and Y axis. So this is so fast that you cannot measure it here. So they are using a mobile app to measure the timings. So this is one particular app where they are using the measurement. So you see the complexity, even placing the Rubik's cube, the mechanism in what they have done it. So it goes down. Finished in 6 seconds. So the earlier version, 3 minutes it took. If you want to again mix and see, it will take even lesser time. So a very small step. So within 2 seconds. So this is what is required for faculties as well as students to work on. So I told about industrial robots. So in industrial robot, there is not much to learn about. It's more on degrees of freedom. X-axis, Y-axis, you have 6-axis robot, and you have some end effectors, picking, camera vision, then suction. So all these end effectors are there. But when you have to work on a real scale, prototyping is must. And there are many Western universities where they have built robots using this prototyping kits and publish very good papers because basically it's not just programming. You can program using C as well as Python, so which are more of a open source. So in Western countries, when you use open source, they are much appreciated. So it's a kit. Using this kit, any kind of application, what you imagine, you can build it. Yes. Next one, third video. Okay, this will give. This is the more advanced level, the latest version of kits. It's called Abilix Krypton. So you can see all these parts, you can remove it and put it back in your kit. And you can just, this video shows what different kind of robots that you can build. The simple gearing mechanism. Mechanical people, they talk about bevel gear, spur gear, but students never see its operation. So this is a real time factory automation. So the creativity is limitless. It's only that you define on your objectivity, what project that you have to do it. So depending on that, so this Krypton, it has got more than 750 building components. It's got more than 9 sensors, and it has got ARM9 controller, more advanced, multiple IO lines, and it can be programmed using Scratch, Python, C. So it's completely research oriented also. ARM9. Yeah. So this is a color sensor. So the first lab we have established in PSNA, Dindigal. They have a full-fledged lab of Krypton series. So we are not saying what robot to buy. We are saying what robot you define, what robot you want to build. That is particular kit will provide, and you can build any kind of applications. And next. Okay. Video ಆಯ್ತು. Okay, this is again, you might have seen some of the videos earlier. Resource people, they might have shown from Boston Dynamics, right? Because morning when I came in, I saw some video playing on Boston Dynamics. So 14 years back, Honda started with a complete walking humanoid robot. So it's a simple operation, but as you know, even for humans, when they sit and get up, your center of gravity plays a crucial role. So balancing of these robots in biped, that is 2 legs, it's a daunting task. So the first ever humanoid robot without falling was developed by Honda 14 years back. It was named as Asimo robots. So next video. So this is the Boston Dynamic video I thought. So 14 years back, it was a great achievement when a humanoid robot walked and did stuff. And this is the stage what we are in now, where different elevation, inclination, the distance, job, the balance of robot remains stable. So this, I think, one of the greatest achievement in the robotics field. Because over the years, your gyro sensors or developing PID controllers, it became more complex and it became more accurate. So that's the reason these robots also became more stable. Next video. So basically the center of gravity remains the same with different positions. So basically this is coming closer to the reality, making a robot as a slave. does cartwheel also. Okay, so another disadvantage what we have in Indian ecosystem, India has never developed a sensors. So that's where other countries have got hold of their actuators, sensors. Next. So this is our current stage what we are in terms of the balance. So you might have seen some gymnastic movements. So exact gymnastic movements, the robots are doing it. So basically Boston, Boston Dynamic, one of the very well-known research in domain. And next institute in Tamil Nadu, I see Shastra is doing very well in robotics. Okay, next. Presentation, PPT.
To design these kind of robots, does it take maths as most of the part or logical thinking?
See, maths is there always. So maths is integral part of any motion or any inclination, starting with your even standing. The inertia is all maths. Next comes your design part. So whatever design you do, it depends on your design how it balances on the one particular. If you take again, when we say robots, we are only talking about humanoid robots. Even the projector, it's a robot. We don't talk that it's a robot. Your ATM machine, we say ATM machine, but it's again a robot. So this is only thing, the human mindset, where we want a robot to be a human slave. That's where this kind of research line has gone. The biped robots, what we call them, the two-legged robots. Okay, so this is what, even in your prototyping, you can create a humanoid robot. Okay, so again, this model, if you see, there are two wheels. So heard of Segways? It's a two-wheel vehicle where a person can stand and move around. There is a handle also. Some Segways, they don't have handle. Only thing is, on the Segway you can stand, just lean forward, it will move forward. Just balance your weight on the right side, it turns right. So you lean backwards, it stops. So this is the Segway in a prototype manner. So this robot balances in the two wheels. Next. Okay. So the technology which redefining each and other technology is your AI. So AI, basically, most of you think it's more on IT domain, but there is a huge disruption in electronics domain also. There is AI in electronics, there is AI in mechanical, there is AI in civil, there is AI in electrical. So that's where you see recent AICT MODROPS. I think MODROPS is almost 20-year-old funding. They used to give 20 lakhs. But this time what they called for proposal is all this domain. If you give a proposal on AI with mechanical, they are accepting. So as a pilot project, they had called only for government institutions. Next, I'll be calling for private institution. So basically, the earlier robots, you were defining the environment. Then again, the paths were defined. Then particular movement was fixed. So keeping all this in mind, you used to develop the robot. But now what has happened is it's data driven. Data of what? Data of sensors. See, earlier basic robots, what they have to do is to detect and sense that particular environment. But now the AI picture, when it comes in, this sensor will measure the entire environment. It's not just particular location or particular value. So it will have the value of all the location, and what particular task it has to do, it will it does that. So basically it's learning from the environment. So earlier particular sensors, for example line following, basically we can use color sensor. Just if you use black and white floor and black line, you can use a grayscale sensor, so which detects only black and white. So this particular aspect, when you develop a robot, so you are defining the environment. Your floor has to be white and your line has to be black. So now what is happening? Even this yellow floor, I put a black tape. I can make a robot to run. It's not just white part. So that is, it's multicolor. That means it is having data of multiple sensor data of different colors. Okay. So one of the first implementation of AI robots was in Amazon warehouses. So it's started with basic line following robots, okay, because Amazon they had to categorize, cater to multiple parcels with multiple timeline, with multiple size. All these parameters matter. So basically they started with this. So that's where in-depth analysis of AI started in robotics domain. So one is real-time perception. So if I think you'll get those videos in your YouTube. When I say Amazon warehouse, it's not just one robot. There are more than 200 robots working in tandem. So it never crashes with one another. So this is a particular perception, and last 5-7 years we are talking about another niche domain in robotics, that is a what we call it as cobots, or in general term it is collaborative robotics. So again, before AI, when we talked about collaborative robotics, it is involved machine and a human. So if I am assembling something on this table, a particular robot, when I am making a movement, it stops. So again, this is predefined. Okay, that is one particular boundary condition you are getting. When I am moving, it stops. When I move out of this place, the robot starts working. But integrating AI with cobot, what is happening? If I am moving here, it will never come near me, but it moves to do a next particular task without colliding with particular other application. Okay, so this is what the impact is happening in AI. So another aspect that is coming is something called, first we had a technology called cloud computing, then came edge computing. Now we are talking about cognitive computing. In future we are talking about quantum computing. So quantum, again, there's a lot of buzz in academic circle about quantum technology. But if you see quantum technology, it is not a new technology. It is defined long time back, more than 200 years, because it's a pure physics, mechanical physics, and in that all type of formulas, all types of theory was formalized in quantum, but practical implementation was never possible. So this was made possible only because of AI. So that's where we have talking about quantum technology, reigniting the theory and concepts of it. Okay, so this is one of the domain where I'd like to stress on. Data acquisition is one of the very key criteria in multiple industries, especially in the manufacturing and robotics. So what I've seen in the academic circle is they have never introduced data acquisition in their curriculum or practically implemented. So you have a monopoly market. You have National Instruments where they provide LabVIEW and their data acquisition boards. Again, college has to invest in their software, and they have to invest in the hardware. Again, all these products are imported. So what we have done is, since we have done multiple products, we understood this problem statement in academia, and we have developed our own DAC module. So this is where we are starting with basics, starting with your first year's C language, where a student programs a hello world. So in the hello world, what student is doing is writing the program, seeing the display on the monitor. So what we are saying is that hello world data you acquire in the hardware, connect it to another PC or another project, and check how this PC to PC communication working. So this is where is most of the manufacturing and robotic industry has the requirement in the data acquisition part. So there are multiple aspects of it. So instead of me talking about theory, we'll do some practical, one or two examples using our own SIMS data acquisition model. Yeah. So basically we are trying to avoid proprietary software like LabVIEW. Instead of that, you can use C and Python. So we are starting with this basic from hello world to the next level. We are talking about center of excellence in data acquisition, in renewable energy, climatic change, in automotive electronics, in EVs and battery management. So these are the sector we are exploring using our DAC module. So I have my colleague here, Omkar. Give the words. GPI. So over the years, we have developed more products to education sector. This was developed almost 10 years back. It's a general purpose IO boards. It's got LED, relay, DAC, ADC, all these features. Another GPIO, it got LCD, LED displays, and hexa keypad, and DAC. Yeah. So this is our product. So this is more versatile. So uh, this has 32 I/O lines. You can integrate with any inputs and any output, and it is USB powered, and it has got HDMI port also. So multiple tasks can be done. Two disadvantage what I see is academic circle are not working on Linux, or they're not working on Python, because when we say academia, you have to more tend towards open source tools, but this is not happening. Even in your mechanical, there are a lot of open source tools for your CAD designs, but mostly you prefer three: ANSYS, Altair, or Autodesk. Yeah. Ready, Omkar? Don't go with theory. Just show the program and implementation. ಇಲ್ಲ ಬಿಡ್ಲಾ?
Mic off. Keep it on that table.
Huh. So good afternoon. I am Omkar from Silicon Microsystem. I'm working here as an embedded engineer. So basically, this is the data acquisition model. So basically, let us know what is data acquisition. It is nothing but collecting the data from the environment and storing it and analyzing it, and also to manage the data how we want according to the application side. So it can be used for the various purpose. So let us know what all features it has. So this is a custom USB DAC module. So basically, as sir said, it has a 32 I/O lines, and it is programmable by C and Python. So the maximum speed of USB DAC is 20 megahertz, and it has 4 ports, so that in each port you have 8 I/O lines, and you can proceed with different type of communication protocols like UART, SPI, I2C, and you can perform multiple motor operations. You can do anything by using a data acquisition, and it can read an analog or a digital data. So this is a USB DAC. So I'll not go deeply into the electronics part. So let us come with the demo. So now what I'm doing is from this USB DAC, I'm just reading the LED status and I'm controlling according to what I want to do. Like you can run a timer or a different patterns or set a LED 1, 2, 3. This is a simple one. I'll just show with the simple demo, and in the same manner you can develop an application one. So according to the mechanical department or in the robotics field, you can read a stress, strain or different parameters, and you can monitor that. You can convert analog or a digital data. You can do anything. So in this, what I have done is, in this we have a source code, and this is the wrapper code. So wrapper code, you can write it in a C or else as well as in Python. So this is the application. So you can see here, I'm generating a pattern here. You can stop this and go with a different pattern. You can see the live status. We can set individual LEDs.
Show it again. So basically this is a data acquisition module, and particular LED connectivity you have scheduled using C,
Python.
with
So what I have done is, I have made my own GUI part. In the same manner, you can, depends upon the application what you want to do, and you can monitor the data, control a robot or a reader data, and store it and analyze it, and you can also check about the performance.
So one more huge requirement in the industry is to develop these kind of GUIs features, especially the mechanical as well as electronics part. It is one of the highest paid job in the domain market. So people with strong C and Python knowledge, they can develop this kind of user interface.
You want hands-on session on this? You want to do?
So you go back to my PPT. I'm PPT. Okay. So in 2-3 slides, I'll wind up the session. Okay. One is this is the very critical component on the data acquisition part. So now we are talking about not just a simple user-defined particular environment or a fixed boundary data. We are talking about AI data. That means it has to have all the environment data in all the positions, all the different parameters depending on what application robot you have. So that data processing becomes more complex. That's where you have all this NVIDIA GPUs, which has higher processing capacity, are used in different kind of applications. Okay, so this is one example, the impact of AI that we have seen in the real time during the Operation Sindoor. We call it as S-lamps. So this is very, I think you talk about this technology, it will take a long time. So these are some of the research direction that we are heading at, any mechanical faculty. So one is the design aspect. So basically earlier, when I say ATM as a robot, so particular your entire body is designed and it is fixed in one place. Now we are talking about ATM machine moving around. We are talking about QR codes. We are talking about ease of doing payments. So all this, there is a huge research aspects. I told you about data acquisition. That is one of the highest demand. So edge computing or the edge eye deployment. So what used to happen in cloud computing is used to store the data, send it to the cloud for storing the complete data, and when you needed the access, you had to access back from cloud. So it was taking a delayed time. So something for this room, I can have one particular server where any particular application, I can send the data to that server, get back the data in real time. So that system is nothing but your edge computing. And then comes your cognitive computing or something. This is a very interesting domain of robotics, is your digital twin. Heard of digital twin? What it is?
Well, it is the virtual replica of real world.
Real world, okay. So virtual replica of real world, rather than that, it's a virtual replica of your personality. So in the future, how is it going to happen is, you will have one robot with you, okay? You will be constantly interacting with it. You will be asking questions, you will be feeding data, and one point of the time, this robot will start replicating you. So that's where we are talking about cognitive computing and digital twin technology. And of course, in AI, we are talking about ethics and safety. Okay, so what we bring in is, why I talk about lot of this funding agency. So over my 15 years in academic involvement, we have got almost 50 to 60 crores of funding till now for the institutions in multiple funding agencies from DST to AICT, and so we are looking at particular institution strength as well as particular faculty strength, so that we can coordinate and we can apply for multiple fundings. So when we talk about the funding parts, so next 5 years is a huge funding that academic institutions are going to receive. So basically, you had DST SERB, right? Heard of SERB? DST SERB, that is one of the highest funding agency in India. They fund up to 15 to 20 CR. So now what government of India is planning is to bring all these funding agencies under one roof. Now they have already brought all the DST funding, DST SERB under one part, that is your ANRF. Heard of ANRF? Anusadhan National Research Foundation. So in next 1-2 years, all your government fundings to academia or research organization, it will come under ANRF. So it's a one window. So once you apply, you create the account, they'll have a complete data and track of it. Recently, they had called for ANRF MedTech mission. So this is one of the government's plan to bring in indigenous medical equipment and devices. So currently what is happening in India, you go into any hospital, starting from your small digital thermometer to your high-end machines like MRI, everything is imported. So India wants some indigenized devices and equipment. That's where they had, I know ICMR is the guidelines body in the medical sector. So these are the people who provided guidelines during pandemic time. So they are into lot of medical research, and from ANRF and ICMR, so they called for proposal, and they were ready to fund, if the project is good, they are ready to fund up to 30 CR. So we are talking, so gone are the days when funding agency were funding in lakhs. So we are talking about in crores. So one more active funding what is there now is ANRF AI for Science and Engineering. So again there are different categories the government of India has defined. So that medtech was a separate mission, medtech mission. So like this government has formulated multiple missions. You have a health mission, you have a semiconductor mission, you have India AI mission. So under multiple missions, there are huge funding that has been allotted, and the next level is under ANRF. These funding agencies will call for the proposals. And if you see the AI in science and engineering, if your product or your solution is really good, they are ready to fund you up to 50 CR. This is never seen kind of a environment in the Indian research domain. Last week, Prime Minister Modi, he made one more scheme. It's called as RDI scheme. So 1 lakh crores has been allotted to RDI scheme only for research and development. So that's why next 5 years there will be a huge funding in academic circle. So try to utilize all these things. And of course, when we are talking about this larger funding, at least your base level, some kind of lab setups, or like what we have, the data acquisition, it's a multidisciplinary data acquisition. So you can have it as a centralized skill lab. You can have some over the period of paper publications happening. And when this larger funding comes, so when they are funding, even in your 3 months back, AICT, they had called for AICT RPS, AICT Research Promotion Scheme. So that is there from past 25 years. But this time unique was, if government is funding, at that cost, you come up with the product. So the theme was AICT RPS Lab to Market. So fund was 50 lakhs. So 50 lakhs we are giving, you come up with the product. So that is the level the government is initiating. So to go at that particular commercialization or patents or the product stage, first ground level, you should have some basics. Robotics, data acquisition, it's a multidisciplinary. You can have it. We suggest lot things in electronics domain because the crowd is more towards mechanical. So this prototyping of kits, again, if you have 5 to 10 kits, you'll have a wonderful lab for your robotics lab. Currently, we are working with multiple board of studies to involve this kind of products in the curriculum, so that more of application oriented or the research oriented labs are created. So what we are doing, it's not just the robotic domain, especially the electronics domain. We are creating the complete ecosystem for COE. See, earlier what used to happen in Center of Excellence, you had big brand companies coming in and establishing lakhs of rupees of labs. and they used to give you a brand and set up multiple infrastructure equipment or the software that used to go into 30 to 50 lakhs. And what I've seen is these labs or this center of excellence, since there is no support system from the bigger companies, these COEs becomes idle. So we don't want to keep COEs idle. We have to make it function. So that's where we are creating the ecosystem. So where we create the ecosystem in simple 3 steps. First is skilling of faculty, skilling of students, and then if we are doing the longer finishing school program, we are even talking about placements to the students in the core companies. Then comes your next level. We identify particular faculty, their strength, and what domain they possess the expertise, and based on their profile. So basically, government grants divided into 2 categories. One is research grant, another is infrastructure grant. So MODROPS, or in Karnataka you have VGST, multiple infrastructure grants are there, and PI based, that is project investigator based, is completely purely your profile based, your research oriented funding. So these are quite crucial aspects, and we work intensively with the faculty community. So we have done more than 300 faculty development programs. Now we are in a stage where multiple institutions have started calling for the FDPs, and we are finding very limited time. So we are trying to avoid FDPs, and we have come up with one more program, that is one day will take you to the industry itself. So last month we went with 2 industry. One is PCB manufacturing plant. So it's completely electronics, how a PCB board is completely manufactured. Second is we took them to TESOL. TESOL is the only Indian company which makes chip testing. They have a complete chip testing facility, almost 9 to 10 crores of equipments are there. And next we are talking about, this was more towards electronics. Next, in Biddi you have Toyota plant. Again, complete automation and robotics aspects are there. So if I schedule that industry visit, I'll just send an invite so that you can attend. It's a one-day program. Only thing is we are not charging anything. You have to come to the venue, and we'll take all the permissions from the industry, and it will be limited to 25 to 30 faculties. So that now you should analyze what is happening in the industry, and the same thing you have to go and discuss with your peers as well as. So this is one way we thought, instead of especially the post lunch sessions, instead of me standing here and talking, one day in industry itself you come and see how these robots are working. That's more than enough. Only thing, again, you have all this guidelines, NAC, NBA, ACT guidelines. You need 3 days FTP, 5 days FTP. It happens. So we are creating something like this. And when we are working with skilling ecosystem and research level collaboration with faculties, we are talking about getting larger grants. So at this grants level, when we talk, definitely a lot of patents will be happening, and products will be developed. And if the products is really good enough, we are happy to take that product to the market. So that is one aspect. Second aspect, again, as per the guidelines, you have created multiple institution has incubation centers. So again, in incubation, that product, if you want to make a startup, we'll try to get the funding for that startup. So this is complete 3 levels: skilling, research collaboration, and incubation. So we are talking about with an institution with continuous engagement for next 5 to 7 years. Then only you'll have this complete COE ecosystem. Otherwise, just setting up the infrastructure will never move into what we are talking about, patent or commercializing the product or anything like that. So again, especially in robotics domain, last year, government of Department of Coal and Mines, they had called for a proposal where they wanted some robots and drones to be developed, and they were ready to fund almost 20 to 40 crores for this project. Unfortunately, only 2 IITs attended and few companies, and no other academic institution attended this proposal. So you just, being in mechanical domain, we are doing this FDP on robotics. So it's a missed opportunity of 40 crores department. So most probably they might call again. Depends on how it goes. So this is my contact details. So I'm expertised in the embedded domain, robotics, as well as communication domain. Especially under Anna University, we have set up multiple communication lab, 4G, 5G, LTE labs. So it's all core electronics part. And any association with our company, we are open to collaborate. We are more open to in the research collaboration. And we are open not just to sign MOUs, because we have almost 70-80 MOUs just lying as an idle, not in active state. Only because these institutions want it for NBA, NAC accreditation. This happens. So we want active MOUs. Okay. So I thank everyone to be very patientfully hearing, though even I was feeling sleepy. Because when we say robotics, it's not the theory session. It has to be hands-on. And at least next time when you are taking not for talk, you give us 3 days. We can have a hands-on session. And one more aspect I told you in between my presentation, most of the academic institutions or the faculty community, they're missing out on using open source. So there is something called ROS. Heard of it? ROS. It's an open source. I request your faculties as well as students. ROS 2.0 has come. It's open source. Try to efficiently use that tool. Okay. Thank you, JSS team, and thank you all the participants for inviting us and bearing with me in the afternoon session. Thank you.
Thank you, sir, for highlighting the need for the funded projects and the opportunities what are existing, not only from the government of Karnataka, but also from the government of India. Silicon Microsystems has many MOU, but they are prominent in Bangalore. They have a MOU with VTU as well as Anna University. So they are doing exceptionally well, and especially in embedded systems, as sir pointed out. So definitely, sir, next time we will give you more time so that 2 or 3 days you can have more of practical exposure. But because of the schedule, what is very tight, so it's a limited time what is given. So I thank you, sir. And one more thing is VGST, I think it's calling this month end or something. You can always apply. And I request, I'll add sir in the group, and I request him to share the links.
I'll add one more point.
Yeah.
So this VGST is a state government funded, and Last year we had supported 5 institutions and actually 6 institutions, and out of 6, all 5 institutions received this VGST funding. And in VGST you have different grants. One is your research grant, that is for 40 lakhs. Then comes your infrastructure grant, CAPEX level 1 and level 2, that is 30 and 15 lakhs. And then comes the individual faculty oriented awards, where we were around 4 to 5 lakhs. So all this category we have got the funding. Actually the 6th project also we had to get it. Problem was with the committee called for the presentation. Unfortunately the PI's father-in-law passed. So she had to go to native, and PI could not justify in front of the company. Otherwise 6 or 6 you would have got 100% stipend.
Let us try this time, sir, from SJCA. So I thank you, sir, for giving your valuable time and all the knowledge that is shared. So now I request my colleague, Professor Baswaraj sir, from our own Mechanical Engineering Department, to do the honors. We have a group photo.
Sure.
First page, actually. First page.
My name is Prachi. I'm from the Advanced Institute of Technology. So I'm actually in IT department. We already have